Welcome to Library Academy, and this is our continuation on gamma functions. So you have to evaluate integral from 0 to 1 x cubed into bracket x ln 1 on x dx. Well, given that the general definition for gamma function, which is gamma n equal integral from 0 to infinity x to the power n minus 1 e to the power minus x dx. We would like to massage this question up to a point we will get something like this, so that we can use the idea of gamma functions to solve this integral equation very easily. So what we are going to do is that we are going to use substitution to substitute the values here and try to massage them to get what we really want. And comparing this question to the general definition for beta functions, which are the form integral from 0 to 1 x to the power n minus 1 into bracket 1 minus x into bracket n minus 1 dx, you could see that this one is more closer to gamma functions as compared to beta functions. The nature of the question will even give you a hint as to how to go about it. And anytime you see gamma problems which involve natural log term, mostly you are going to do your substitution, and the substitution is also it might involve in two-step substitution. So once you see a problem which is not straightforward that you can equate powers, so you just keep in mind that you are probably going to use substitution to massage the question. So let's continue. So with this problem, we are going to let u equal ln 1 on x. So if u equal ln 1 on x, let's eliminate this ln1, this ln nature. So we know that ln has a base of e. So if we have ln 1 equals 0, it means that the base here is e. So e to the power 0 to give us 1. So generally, if you are giving ln a equal u, so u to the power e to give you a. So u to the power, e to the power u to give you a. So you can confirm that by using your calculator. So ln1 is 0. So let me punch e to the power. ln1 is 0. So e to the power 0 to give me 1. So e to the power 0 to give me 1. And you can see that. So this right here is to tell us that e to the power u equal 1 on x. So e to the power u equal 1 on x. So now let's keep this in mind. So what we also need is x. We need to also look for the value of x so that when we are making the substitution, because our substitution is generally going to be in use. So we have to also look for the value of x since we have x terms in the expression, so that we can replace those by u to get a uniform substitution. So we want to make x the subject. So multiplying x throughout, you see we can get x u to the e to the power u equal 1. So x e to the power u equal 1. Because we want x, we just divide both sides by e to the power u. So we are going to get our x to be 1 over e to the power u. So, and that is the same as inverse of e to the power u, which is e to the power minus u, right? From indices, if we have 1 to the power 1 over 2 to the power 2, is the same as writing it as 2 to the power negative 2. So if we have 1 over 2 to the power x is the same as 2 to the power negative x. So now we also have the value for our u. Keep it in mind. One thing we also need to know is corresponding value for the x. So we also have to look out for the x. So we know our u right here to be equal to ln 1 on x. So we need to look for our du. So du is going to give us the differential of this. I mean, derivative of this, dx. So it's going to give our derivative of ln 1 on x dx. And how do we do that? We know that the derivative of ln u is the same as derivative of the argument over the argument. So, and now that we have ln 1 on x, so we are going to find the derivative of this divided by the whole of this. And 1 on x can also be represented as x to the power negative 1. So this, to find the derivative of this, we multiply everything by the power, so minus 1, then x to the power minus 1, and the power will decrease by 1 again, minus 1. So this is going to give us minus x to the power negative 2, which is the same as minus 1 on x to the power 2. So now that we know the differential of the derivative of this, so it's going to be the derivative of this over all of this. So this is going to give us minus 1 on x squared all over this. So 1 on x. So this can also be written as minus 1 over x squared. We want to remove the division sign. We just multiply by the reciprocal of this. So at the end of the day, x will cancel x here. X will cancel x, remaining 1x. So negative 1 over x. So that is for du. Now that we know the differential of this, so our du equal negative 1 on x dx. And like I said earlier, our substitution is going to involve only in u's. So we need to replace this by its corresponding value. So we have x here. That is why we already solved for the value of x. And we know that x here equal to e to the power negative u. So let's replace this place by e to the power negative u dx. So now, would you like to make our dx the subject? So making our dx the subject, let me write everything here. So we have du equal minus 1 all on e to the power negative u dx. So we can go ahead and multiply 2 by e. So at the end of the day, if we multiply 2 by e to the power negative u, and here by e to the power negative u, e to the power negative u will cancel that one here. So let's say e to the power negative u du equal minus 1 over e to the power negative u multiplied by e to the power negative u. I'm multiplying through both sides. So this is going to take care of that, remaining minus 1 dx. So we are going to get e to the power negative u du equal negative dx. Because we are looking for x, let's divide through by negative 1. So our dx is going to be e to the power negative eu negative u du. So if we divide through by negative 1, this negative sign is going to affect this, bringing our negative sign here. So we also need to know this. And now, because we are making substitution, our limit will also might be affected. So we have to check our limit and see. So we know that u equal in x. That is a substitution that we are making. So if x equal 0, what happened to our u value? So if x equals 0, we are going to get in 1 on 0, which is equal to positive infinity. So looking at this limit, we are approaching 0 from the right side, from 1 to 0. So going to give us positive infinity. So if our x equal 1, what will happen to our limit? X equal 1, we are going to get ln. Don't mind when I say in, it's not is ln, but I'm used to saying in. I don't know why. So 1 on 1. So this is going to give us ln 1, which is 0. So now notice how our limit changed. When x equals 0, that is where we are going to have the infinity sign. And when x equals 1, we are going to get 0 there. So let's write it as such for now. Now we can go ahead and make our substitution. So this is the question right here. And now we know what to represent ln 1 on x. And we also know what x is, which is right here. X is minus e to the power minus u. So now we can go ahead and we know that our boundary starts from infinity to 0, because when x equals 0, right here we got infinity. Right here we got infinity. When x equals 1, right here we got 0. So let's write it as such. So 0, and our x is e to the power negative u. So e to the power negative u, but all to the power 3. All to the power 3. And into bracket x e to the power negative u for u. And our ln 1 on x to give us what? U, as we said here. So u, actually, so add half here. This is to the power half. Everything here is to the power half. So u, ln 1 on x is u, all to the power half. And now, what is our dx? We already saw for our dx. And our dx right here is negative e to the power negative u du. So minus e to the power negative u du. And one thing you should also remember for general integral rule, if you have integral of a to b f of x dx, to flip the boundaries, you can, this will definitely give us, negative integral of a to b will change the boundary from b to a of f of x dx. So it's generally that a negative sign here can actually change the boundaries, the position of the limits. So if we are to simplify this further, we are going to get, so because of the negative sign here, we can actually flip the limit. So the limit from 0 to integral. Now that we are in the zone of gamma functions, from 0 to infinity. So this power here is affecting this e to the power negative u. So we are going to get e to the power negative 3u, just multiply through. And this power half here is affecting e to the power minus u. So e to the power minus half u. So, and this u here, this power is also affecting the u. So we have u to the power half. Now our negative sign is no more there. And e to the power negative u. Then we add your du to it, the whole term. So now we can group like terms. So e to the power negative 3u, or let's make it this way. Since all of these are multiplying from the law of indices, we can go ahead and add the powers. So let me write this again. Let's bring this e here. Then our last half a u to the power half du. So since these are all multiplying, we can say all of them are in the term u to the power negative u. So we have 3 here, we have half here, we have 1 here. So minus 3 minus half minus 1. We are actually adding, but in the presence of negative and positive sign, we are going to get negative sign. So let me do that on my calculator. So this will give me negative 9 on 2. So all my e terms is going to give me integral from 0 to infinity e to the power minus 9 on 2u. Then I'll bring my u term on half du. So rewriting this, I'm going to get integral from 0 to infinity u to the power half e to the power minus 9 on 2u du. But my aim is to express this term, this whole term, into a form that will look like the general definition for gamma functions. But still, looking at the general definition for gamma functions, here is it. The power of e should be of the form negative x, and this should be of the form, this one doesn't actually matter for now, this one is okay. So I have here u to the power half, that one is okay, but e is not in the form of this. So I have to do another substitution. So in this term, let me use t. So in this time, let me use t instead of u. So far we've got here. So if I let my t equal 9 on 2u, 9 on 2u, not negative 9 on 2u, because I need a negative sign there so that it will come and look like this term here. So I'm definitely going to take this, excluding the negative sign. This is u. So like we did earlier, I need to know what my u is. Because I have u terms here, I have to make substitution to replace everything. So simplifying this term to make u the subject, so 2 by 2 will give me 2t equal 9u. Dividing 2 by 9, my u will give me 2t on 9. So this is my u, the value for my u. So now I have to look for the u so that I'll be able to replace everything here by its corresponding value. So my du should give me, I'm going to differentiate this. So 1 power 1 multiplied by 2 on 9, t power 1 multiplied by 2 on 9 is the same as 2 on 9 dt. This is actually like saying I'm going to find the u dt. It means t is the actual variable that is changing. So my u equal 2t on 9. So du dt equal, I'm differentiating with respect to t, the denominator right here. So this will give me 2 on 9, right? So because I made the du the subject, multiplying this by dt, 2 on 9 dt. So that's how we came. That's how we got this. I know the value for du. Now that I know the value for du, what else do I need? I have to test my limit and see whether everything is okay. So I said my t equal 9 on 2u, right? So when t equal, looking at the limit, when t equals 0, what happened? What will happen? When t equals 0, I'm going to get 9 on 2 multiplying 0, which will give me 0, right? When t equal infinity, I'm going to give me 9 multiplied by infinity, all on 2, which is going to give me infinity. Any non-zero number multiplied by infinity will definitely give you infinity. So this means that I have no problem with my limits. So I can just go ahead and do my substitution. So we are continuing. So now, integral from 0 to infinity, u to the power half, e to the power minus 9 on 2 u du. I know my u to be 2t on 9, which is right here. So 2 on 9t all to the power half, and e to the power, I said my t should be 9 on 2u, so 9 on 2u. So this should be minus u. That is why we neglected the negative sign, because we'll be needing it. And now our du, we got our du to be here. So this means we should replace everything here by 2 9 dt. So now everything is changed to t. This term here, we said t should be equal to all of this, right? So this should be t. At the end of the substitution, you could see that everything is changed to t. Integral from 0 to infinity. So now this power right here, is affecting 2 on 9 and t. So integral from 0 to infinity, 2 on 9 to the power half and t to the power half, e to the power negative t, 2 on 9 dt. So let's actually bring all the constant out. 2 on 9 is a constant, this one is also a constant. So we can have, you know that 2 on 9 to the power half is the same as square root of 2 on 9. So let's represent 2 on 9. So this one we have multiplying 2 on 9. This is the constant coming out. So 0, integral from 0 to infinity. Now we are left with t to the power half and e to the power negative t. So t to the power half and e to the power negative t dt. So at this point, if we compare this, so if we compare this, before that, let me simplify this out here. So multiplying this will give you 2 root 2 on 27, integral from 0 to infinity, t to the power half, e to the power minus t dt. So if we compare this one right here to the general gamma function, general definition for gamma functions, you will see that it actually matches. At this point, the exponent, the power of our e is negative t, and it matches with negative x. So we are good to go. And we know that the reason why we're doing this is to use the idea of gamma functions, right? So we know that gamma n equals integral from 0 to infinity x to the power n minus 1 e to the power negative x dx. So now, at this point right here, what we are going to do is to compare the exponent of this to this. So we are going to equate this to this. So minus n minus 1 equal half, right? So solving for n, let's multiply 2 by 2. So 2 by n giving me 2n, 2 by minus 1 minus 2, 2 by half giving me 1. So 2 crossing right here, become positive, 2 plus 1 giving me 3. So 2n equal 3. So dividing 2 by 2, n equal 3 on 2. So now that we know the value for n, comparing this whole thing to this, we have gamma 2 root 2 over 27 integral from 0 to infinity t to the power half e to the power minus t dt is now equal to, the whole of this to be gamma n. The whole of this to be gamma n. So 2 root 2 on 27. And what the value for n now is 3 on 2 for this problem. So gamma 3 on 2. So this whole thing equal this. So we know this thing is gamma n, and we already calculated for our n, which is 3 on 2. And now 3 on 2, gamma 3 on 2 multiplying this constant. So now what we are going to do is to simplify this, and our final answer will be the result for this whole problem right here. Right, this whole problem right here. So let's see how to go about this. So we know that if we have gamma n plus 1 is going to give us n gamma n. So that is just another formula for gamma functions. So what we are going to do is that we are going to find a way of expressing this 3 on 2 into the forms a number plus 1 so that we can apply it in this form. So mostly what I do is that I equate this whole thing to 3 on 2. So n plus 1 equal means something plus 1 will give me 3 on 2. So it means, let me solve for n. So multiplying 2 by 2, I'm going to get 2n plus 2 equal 3. So 2 crossing, I'm going to get positive 1, 2n equal 1 on 1 here. So at the end of the day, dividing 2 by 2, my n is 1 on 2. It means this one, gamma or 3 on 2, is the same as gamma half plus 1, right? So something plus 1 will give me 2 and 2. So and n here is half. So after I'm able to express this in this form, so gamma half plus 1, I can go ahead and say n gamma n. And comparing this right here to this, where is what is the value for my n? N here is half. So this is going to give you half gamma half. And gamma half is a constant, square root of pi. So this is going to give me square root of pi on 2. Just multiplying 2 by half. So square root of half, pi on 2. So let's apply it here. So this term here will give me on 27 multiplying half gamma half, right? And half gamma half is going to give me 2 root 2 on 27 square root of pi all on 2. And you could see that since these are multiplying, 2 here can take care of these 2, and I'll be left with square root of 2 square root of pi all on 27. And according to basic principles too, you can also, general mathematics, you can also write this in this form. So 2 pi on 27. So this will be our final answer for this problem. Thank you for watching, and don't forget to like this video if you found it helpful. See you in my next videos.